Hello everyone, my name is Mohamed Maouche and I'm here to present the linkability metric for the Voice Privacy Challenge 2020. So this metric was first introduced for the evaluation of biometric template protection, but can be adapted to any binary task. In our setting, we have as input the scores outputted by the speaker verification systems with two types of trial, the mated ones for same speaker or non-mated ones. The goal of this metric is to see how much we can separate between the distribution of mated and non-mated scores. Starting for this definition, by using some transformation with the likelihood ratio and the prior ratio, this is the formula for the local measure of linkability. And we can go to the global measure of linkability using the integral over all mated scores. Here on the figure on the right, we can look at the two distributions of the mated and non-mated, and we see that the linkability is high whenever the mated distribution is separable, non-overlapping with the non-mated distribution. Let's talk about the advantages and disadvantages of this metric. First of all, there is no notion of threshold or attacker. If you compare to ER, CLLR, MIR, there is this implicit threshold that decides that if the scores are higher than the threshold, they are supposed to be a mated trial. It is not the case for linkability. It's just see how non-overlapping are the distributions. This is what gives us the second advantage. Any local separation between mated and unmated case can be detected. Here's an example. In this case, where the administration method assigns the speaker A to either the left cluster or the right cluster, and leaves the speaker B in the middle cluster, we can see that we have this distribution of score where some mated scores are lower than the non-mated ones. In this case, linkability will consider that there is low privacy because the cluster are easy to detect, while CLLMA gives a high level of privacy. So this is what difference we have with linkability. This comes from the way it is estimating the LRs. In CLLR, the scores are directly the LLRs. For CLLR mean, the scores are calibrated using a rising function, meaning that the order doesn't change. While for linkability, we use the histograms of mated and non-mated scores in order to compute the LRs. But to compute these histograms, we need bins, and the usage of these bins for the estimation of the probabilities gives us the first disadvantage, is that this method is not exact. The usage of bins is not an exact computation of the probabilities. The final disadvantage is that it's mainly focused on the mated case. It doesn't care about the strength of non-mated evidence during its evaluation. It comes from how it is defined. Basically, this case where it's non-zero is only the case where the mated scores are there's more chance of being mated, and even in the global measure, we use the integral over all mated scores. Let's move to the evaluation using this metric. If we consider what has been shown already with the other metric, we see that there's no much difference. The order of the system is mostly the same, and even further, if we compare the result of two metric here on linkability, so one minus linkability and ER, we see they are all close to the diagonal, meaning that they are supposed to give similar result and order between linkability and ER. If we compare linkability and CLLR mean, here in this figure, I'm showing for each record there is one data set, one attacker, and even one system. So we're not averaging the result, and we're comparing the unlinkability with CLLR mean. And here we can see that it's really close to the diagonal, meaning that in most cases they give similar results, similar privacy levels results for these different cases. There is those three records that are kind of different. We see that they are not exactly close to the diagonal. This is the distribution of scores of this example, and we see that there is a bump here on the left where mated scores are lower than non-mated scores. This is why linkability considers this as a privacy risk, while a metric such as CLLR we consider as errors, so it will give 100% of privacy, while CLLR mean will be more around 83% of privacy. Thank you. If you have any question about the metric or about the result on this metric, we'll gladly discuss it.